So sometimes it's super useful to have a vector that points in some particular direction that you're interested in, but has unit length. So for example, let's think about the vector 0, 3. So I can draw a picture of this pretty easily. So vector 0, 3 is basically just, this is starting at the origin and pointing 0 units to the left or right and 3 units straight up. And if I wanted to manufacture a vector that is pointed in that same direction but has length 1, well, I could do that pretty easily, I guess, because this vector, I'm going to call it u, 0, 1, points in the same direction, and that has length exactly 1. This is easy because this is a vector that's just got kind of one non-zero component, so we can see right away, like the length of this one is 3 and the length of this one is 1, and of course they're both pointing straight up, so they're pointing in the same direction. But how can we do this in general? Well, let's see if we can figure it out. What are we really doing to get from that vector v to the vector u? Well, we're cutting the vector v down by a factor of 3. So we're basically multiplying that vector v by 1/3. Right? We're cutting it down by a factor of 3. And that value, what is that, that value coming from? That's the length of the vector v. And in general, this is going to work just like it sounds like it's going to work, right? So if we're given a vector, let's say a, that's equal to maybe some x, y, the length of a is the square root then of x squared plus y squared. And to get the vector that is of length 1 and pointed in this same direction, that's a unit vector in the direction of a, what we're going to do is just take this vector and multiply it by 1 over its length. So that unit vector in the direction of a, which is sometimes denoted like this, so it's u is for unit and then a subscript with the name of the vector that's describing the direction. This is just going to be 1 over that length of a times the vector a. And now the length is just a scalar. So what we're doing is scalar multiplication. So this ends up being, let's see, this will end up being, in this case, x over the length of a, y over the length of a. The length of a, again, is that square root of x squared plus y squared. Maybe let's do one numerical example. Let's find a unit vector in the direction of 6 minus 2. All right, so first thing we need is the magnitude of this vector. So the length of 6, 2 is the square root of 6 squared plus minus 2 squared. So it's the square root of 40. And so the unit vector in the direction of 6, 2 is just going to be 1 divided by the square root of 40. So that's 1 over the length of the vector times the vector itself. And so that's our unit vector pointed in that direction. And this formula, this basic idea, works in any number of dimensions. So in any number of dimensions, the unit vector pointed in the direction of vector a, it's always equal to 1 over the length of a, that's giving us that scalar, times the vector a itself. So that's unit vectors.